Please, while
Hello
watching this
guys,
video, make
welcome
sure
to
you
my
watch
YouTube
alongside with
page.
a piece
In
of paper
this
and a pen or a pencil.
video
Make
tutorial, we
sure
are
you
going
have a
to
graph
see
paper by your
um,
side, a
how to
pencil,
answer this
and an
question on
eraser,
linear
so that
reduction.
whatever
The
activity I'm
question
doing here,
reads,
you make sure you do exactly the
the
same thing to
variables
become
x and y
acquainted with the
are
methods.
related
And please,
by,
if you have not
by the
subscribed to this
law
channel, please just click
y
on the
equals to 10 log to the base
subscription
10 of
button,
a
that red
plus
button there.
bx, where
Once you
a
have
and b
subscribed,
are
it will be written in past
constants.
tense with a Z at the end. So
Approximate
make sure you
values
subscribe,
for y
because that will encourage
corresponding
me
to the
to
given
create
values of
more
x
wonderful
are
content
tabulated below.
for you
So we have
guys.
x and y, that's a table as you can
Enjoy your
see.
video.
By drawing a linear graph relating 10 to the power y and x, there is an error here. So there is relating 10 to the power y and x, comma, estimate to one decimal place the values of a and b. Roman numeral 2, the value of y when x is 1.5. So let's go straight into answering this question. We have uh, the data given to us, and we were told that they are related by a law. Y equals to what? Log to the base 10 of what? A plus bx. So that is a law. Now we are going to see how to change this form, because if I have it in this form, it is not in linear form, right? So we are going to use the laws of logarithms here to simplify that expression. And we know from logarithms, we know that if the log of x to the base a is equals to n, it is equivalent to writing it in the form a to the power n equals to x. Following this property, I'm going to apply it here. It means that I'm going to have, this is equivalent to writing it as 10 to the power y equals to what? A plus bx. Yeah, just following this property. And also you can equally use the inverse property here of logarithm. So let me fit in the table with the values that were given. We had x ranging from 1 to 6. For the 10 to the power y, it means that for all the values of y here, when x is this, I look for 10 to the power this value. So I take 10 raised to the power 0.857. It gives me 7.19. So I'll record it to the nearest two decimal places, right? I'll record it to two decimal places. I have 7.19. I'll do the same thing for the other one. 10 raised to the power 0.924. It gives me this value 8.339 to the nearest whole to two decimal places. Now I continue the list like that. I take 10 raised to the power 0.982. It's going to give me 9.59. You continue the list, I'm going to have 10.79, 11, 11.99, and finally 13.21. So that is the new table of values we have gotten. Now our goal is to plot a graph of 10 to the power against x. Let's go now to the graph, right? So let's look at the graph. The graph is plotted on a graph paper. This is my graph paper. My graph paper has 23 lines. It measures 23 centimeters by 18 centimeters. So I'm going to choose where my x-axis and y-axis will lie. If I have it on the landscape like this will be my vertical axis, this will be my horizontal axis. Let me use this one for this question. You can use it anyhow. Now, this is made of what? 23 centimeters. This is also it measures 18 centimeters. So that is what I have. So if I'm plotting 10 to the power y against x, the quantity that comes first goes on the vertical axis. So by so doing, I'm going to have, let me put in my axis. So I have this. I know that this is 10 to the power y will go here. 10 to the power y. Then down here on my x-axis, we are plotting 10 to the power y against x. So I'm going to have 10 to the power y. This is now my x. So this is the x here, and this is my y right there, 10 to the power y. Now, once I have done that, it is important for you to know that your graph must not begin from the origin. Once I've inserted my axis on my graph paper, like I've just done, the next thing now is for me to choose a good scale. Okay, the next thing now is to choose a scale. Once you have inserted your axis as indicated, the next thing is to choose a scale that will cover all this data from 7.19 to 13.21 and from 1 to 6. Remember, the scale chosen on the x-axis must not be the same as the scale chosen on the vertical axis. That's why. So I'm going to choose a scale for this one. In choosing a scale, there is a guiding principle. You take the highest value minus the lowest value. So I'm going to show you guys here on my rough worksheets. So on the x, for the variable x, let's choose a scale there. I'll take the highest value minus the lowest value is 1, which is what? 5. Now, since x, I'm plotting it on the horizontal axis made of 18 lines, 18 centimeters, right? Rather than using 18 centimeters, I'll rather use, I'll rather decide to use 16 for safety purposes. So I'll now take this one, right, divided by 16. What the thing is that if you follow my other tutorial, you will see how I created a video there on how to do choose your scale wisely. So when you're choosing your scale, you make sure you leave out 2 units. Okay, once you have chosen that is how to choose your scale. Follow my other tutorial, you get how to choose a scale there. You leave for the 18 units, right? You leave out 2 of them. So I'm going to use 18 minus 2, which is 16. That's why I'm dividing by 16. Now I take now 5 divided by that 16. It gives me 0.3125. Now this is what I do. I will scale it down, right? I will scale it down to 2 decimal places. So I'm going to have, even if this number beside this other one is less than 5, right? Still round it up. You still round it up to what? To 1 and add it to this one. So this one will give me 0.32 when I add 1 to it. So this is a good scale that will enter on the x-axis. To ensure that it will cover all my data from 1 to 6, I see that since I'm using the 16 line, I take 0.32 times 16, it gives me 5.12. My graph is starting from 1. So if I add 1 to that, it gives me 6.12. You see that it has covered all the data from 1 to 6. I will now go and graduate my x-axis. I'll now go and graduate my x-axis. So on my x-axis, let me just bring it down here. On my x-axis, I've used a scale of 1 centimeter. to represent 0.32 units. It's very important to write this so that the person marking your script will know exactly what you have done. Then now, since my graph is starting at 1, the first value is 1, so I indicate there with a 1. Your graph must not necessarily start from the origin, as others will always say. The graph must not start from the origin. So that is what I've gotten. Now, the next thing is that since each of these line is what? 0.32 according to my scale. So I'm going to be adding 0.32, 0.32. And you see, if I'm adding like that, if I'm adding that, I'm going to be adding for after every from 1, I add 0.32. I'm going to have 1.32, right? So if I'm doing that, you see that the graph will become so choked up. So this is what I actually do now. I can decide that I take 1, 2, 3 and indicate a value here, right? So in doing that, I can now just take 0.32 times what? Times 3. 0.32 0.32 times 3, it gives me 0.96. So rather than adding 0.32, so I'll count 1, 2, 3. After every 3 units, I add 0.96 to the previous value. So I'm going to add 1 plus 0.96. I'm going to have 1.96. Please do not use a pen on your graph paper. I'm using this a pen because I want it to be clear. On your answer sheet, do not use that. Then the next, I add 0.96 to this value. I'm going to have, after I count 1, 2, 3 again, I'm going to have 2.92. I count again, I add 0.96. I'm going to have, I count 1, 2, 3. So here is what? 3.88. I keep adding and counting 1, 2, 3. So here I have what? 4.84. I add again. I'm going to have 1, 2, 3. So here I'm going to have 5.8. I count 1, 2, 3. Right. So when I count 1, 2, 3, the last value I have here, let me just indicate. This value here is 6.76. That is what I have for my x. And you see that it has eventually covered all the data. Even if I stop here, right, you see that there will still be space to plot the point 6. That is a very good scale. Look at how it is very clean. Now from that scale now, I also do the same analysis for the scale on the vertical axis. So I come now to the values of 10 to the power y. I notice that the highest value is what? 13.21. The lowest value is what? 7.19. So I'm going to do for 10 to the power y, right? I choose a scale. I take 13.21 minus what? 7.19. That will give me 13.1 plus 13.21 minus 7.19. I'm going to have 6.02. Now, on this vertical axis, right, I have 23 of those lines, 23 of them. So, like I said, when choosing your scale, you always leave out 2 for safety purposes. So I'll leave out 2, right? So since I'm leaving out 2, 23 minus 2, I'm going to have 21, right? So I will divide this value, the range, highest value minus lowest value, I divide it by 21. I'm going to have 6.02. 6.02 divided by 21. I'm going to have 0.28666. It keep going like that. Now, since I said we always approximate to 2 decimal places, right? So even if this value here is less than 5 or is greater than 5, you round it up and add it 1 to the value next to it. So this is what? 0.29. When I round this one and add to 8, it gives me 0.29. So this is a very good scale to use on the vertical axis. So from here now, I'm going to to look at how to see if this scale covers all my data, right? So I'll take now, since I use the 21 lines, I'll take 0.29 times 21. It gives me 6.07. My graph is starting from 7.1. That's the lowest value. So I have 7.19 plus what I had is 13.228. My highest value is 13.21. So you see that it has covered all my data. So it means that I will now go on my graph paper and do a similar thing. That here I was plotting what on this vertical axis. I'm using 1 centimeter is to 1 centimeter is to what the scale I use to represent 0.29 units. So once I've choose that scale, the next thing now is to graduate, right? Since I said that to avoid your graph from being too choked up, you can take for the first 3 lines or even for 2 centimeters before you add to the previous value. My graph, the first value is 7.19. So I have 7.19. I'm going to take now, since I want to skip 3 lines before adding, maybe 2 lines before adding, like 1, 2, 3, I'm going to multiply this value by 3. So I have what 0.29 times 3. It gives me what 0.87. I will now be. It means that 0.87. It means that for every 3 units I count, I add 0.87. So I have this value 0.87 plus 7.19. I'm going to have here 8.06. I add again 0.87. I'm going to have okay. Now since we have chosen a scale of that and we have decided to use by 33 centimeters, so I'm going to take 0.29 times 3. Like I said, we'll be adding that. We are going to be adding 0.87 to the previous value. So I take 0.87 plus 7.19. I'm going to have 8.06 plus 0.87. I'm going to have 1, 2, 3. I count 3 again. That will give me 8.93. I add 0.87 again. That will give me 1, 2, 3. Yeah, so that's 9.80. This is if I'm writing into 2 decimal places, this it should be 0.00. Right. Then from here, I add again 1, 2, 3. Make sure you don't skip one of those lines because it will affect the result. So I count precisely 1, 2, 3. I count again 1, 2, 3. The next value is 11.54. When I add again, it gives me 1, 2, 3. So here I have what 12.41. I add again 13.28. 1, 2, 3. So here I have 13.28. Now that I've chosen my scale, look at how it is very beautiful, my graph paper, well planned. So now the next thing now I'll show you guys is how you can plot these points on this using this scale without stressing too much. Okay, from where we stopped right now, once we have graduated our graph paper like that, we have chosen a good scale and it looks very beautiful. So the next thing is this: how can we now use this our scale of 1 centimeter to represent 0.29 unit on the vertical axis? and this other scale down here to plot points on this graph without stress. This is the method I will explore. I call this, I don't know, this method is very accurate and easy. It is an aspect of rough work. You are not expected to show it on your answer sheet. So I'm going to explore the notion of plotting whole numbers rather than decimals. For instance, if I have these values like this, if I want to plot this thing, it might be so strenuous to identify 7.19 on my graph paper. It might waste me a lot of time. I might come here and I don't know where that 7.19 is actually located, right? So in that case, this is what I'll do. Rather than plotting decimals, I'll use this method. We call it the whole number parts method. This is a method I use in plotting all my graphs while I was in secondary school. So now I will show you guys the method. We call it the whole number part method. The whole number parts methods in plotting the points. Now, the whole number part W is given by the data point, right? Data point divided by subunits. So this data point, it is the values you want to plot. These points like this. That's my data point. Then the subunit is what I used. The subunit is on your graph paper. If you look at these graduations here, you will see some small lines there, right? So you see that for since I've chosen 1 centimeter to represent 0.2 unit, right? These small lines here, that's what I call my sub unit. So for the x, right? Remember what we are doing, we analyze for x, for the variable x and 10 to the power I separately. For x, right? My sub unit, since from here 1 centimeter is equal to 0.29 unit. My subunit, right? My subunit will be equals to what? Since there are 5 of those small lines here, 1, 2, 3, 4, 5. So I'm going to take this to get my subunit. I'm going to take the scale for 1 centimeter, which I choose to be what? 0.29 divided by 5, and it's making sense. So 0.29 divided by 5, and that will give me my subunit. You must not simplify. You can leave it the way it is like that. Don't simplify. Keep it like that. So this is my subunit. I'll call my data point Z and my subunit S. So in essence, my data point, my whole number part W is Z over S. So this is my S. I'll replace it here. So it means my whole number part will now become what? Z divided by what? 0.29 on 5, like that. Then the 5 goes up to give me 5z divided by 0.29. That is for x. I do the similar thing for y. My subunit will be what? For y, since what we have just done is for y. Now let me just put it there, correct it. Because this subunit 0.29 is for y. Now let's analyze for x. So for x, I'm going to have what? This is for 10 to the power y, because we are plotting the 10 to the power y. For x, I do a similar calculation. I take data point, my subunit will be what? The scale I've chosen, which is 0.29, 0.32 divided by 5. I'm using 5 because there are 5 of these small lines here, right? 5 of them for 1 centimeter. So those are my subunits. There are some graph paper that you might have 10, so make sure to count. Okay, I have z divided by what? I mean, what is 0.32 divided by the 5, since there are 5 of those lines. So 1. So from here now, it means that what? The whole number part will be what? Z over what? 0.32 on 5, like that. So when you simplify, I have 5z on what? 0.32. That's the whole number part for what? For x. And this is the whole number part for 10 to the power y. This was on the vertical axis. So I've done that analysis now. This is what I get. For whole number part for 10 to the power y, we have 5z on 0.29. Whole number part for x, the variable x, is 5z divided by what? 0.29, right? I stop there. Now, I'll form a new table, right, for those values. I'll form a new table of values that I will use to plot. Remember, like I said, this is rough work. You are not expected to show it. Okay, I have my table of values. So here, what we have here, whole number part for x and whole number part for what? For 10 to the power y. Those are my notations. I come here now. This is what I get. I will take the first value of x. I'll just show you an example and complete the rest. For the x, right? For each value of x, those are my data point. That's the value of z. To calculate the whole number part for x, in place of 1 for z, I replace it by 1 for the first value. And when I put 1 here, I have 5 times 1 divided by 0.32. That will give me a value of 16. To the nearest whole number, that's why we call it the whole number part method. We want to plot the only whole numbers. You round it up to the nearest whole number. So this is what? 16, right? You round down or round up to the nearest whole number. I do the same for y. Y is what? 7.19, and the whole number part is 5z on 0.29. My z is 7.19. I replace here 5 times 7.19 over 0.29. I'm going to get a value of 124 to the nearest whole number. I do that for all the values, right? And I'm going to get the table 31, 145, 47, 169, 65, 63, 186, 78, 207, 94, 227. Boom. Once we have this data now, this is what I'll plot rather than plotting this one. Remember, what we have done here is rough work, but it's a method, but you don't indicate in your answer sheet. So I'll come now on my graph paper using the same notation. I come with my graph paper. Since I'm plotting whole numbers, I have to number my graph paper in terms of whole numbers. So I'll take now the first data point, right? Remember, 1 represents the first value. I come here, 1 represents 16 on the table for whole numbers. So I'll put 16 here. You can write with a pencil or because at the end you will not indicate on your answer sheet. At the end I'll erase that. Then for y, the whole number part is what? 124. For y, this value here is what? Let me just indicate there. 124, like that. So I have those values, 124, 16. Now, since from year to year is 5, I'll be counting like this: 16, 17, 18, 19, 20. So I'll be adding in terms of 10, so that from year to year is 5, from year to year is 10. 16 plus 10, I'm going to have 26 for the x, that's for the values of x, plus 10, that's 36. That's, you count now. I'm doing this not to make my work crowded. That's why I'm skipping 1. Instead of adding 5, I'm adding by 10. That's why I'm skipping by 1. Then now the next, plus 10, that's 46. Keep going. You skip 1 again and add 56. You skip 1 again, you add 10. That will make what? 66. You add again. Skip 1 and add. That will be what? 76. And keep adding. I have what? 86. And you add again, it gives me 96. I can stop here now because the highest value here for x is 94. I go now to the y-axis. I do the similar arrangement there. This is 124, right? I count, I add 10. I skip 1 and add 10. So I'm going to add 10 there. So I'm going to have 124 plus 10. This is 100 and 134. You skip one line and add again, plus 10. That's 144. You add again, skip one and add 154. Remember, you're adding in terms of tens. So I'm going to skip one and add 164. Add again, 174. You add again, 184. You add 194. You add 204. You add again, 214. You add 224. And the highest value is 227. I add again. So here, after this, the last one, this is 200 and what? 234. So if from here to here, this is 224. If I add 5, I'm going to have 224 plus 5. That is 229. So this one here, this line represents 229, and the highest value is 227, right? So at this point, I can have that. Once I have this data, I'm plotting by the whole numbers, not the data here again. I come here. Remember, everything we are going to do here is corresponding to the original data. So I'll come here now and look at these points. 16 is plotted against, remember, this 10 to the power y goes on the vertical axis. So 16 is plotted against 24. This is the first value here. This is 16. This is 124. I plot the point there. This is where the point is. Then the next 31 goes with 145. So this is 26. This is 26, 31 here. When you count 27, 28, 29, 30, 31. This is 31 on this line. So this is where 31 will be located. On this line now, this is where my 31 is located. I look at where 145 is located. So this is 144. So this the next line towards it is 145. So this is where they intersect here. So I'll plot that point. The next, I plot 47 against 165. 47 is located here. This is 46, right? 47 will be the line next to it. So another my 7 will be located on that line. Then I locate 165. Where is 165? This 164, 165 is the line next to it. So this is where they intersect. I plot that point. Remember, where you plot your point, it must be at the point where those lines intersect. You cannot plot in between the points, in between that space. You must plot on where those lines intersect. You see how easy it is? Now the next value is what? 63. I locate where I have 63 and plot. 63 is plotted against 186. Where is my 63? 63 is located here. This is 66. I count 3 units back. 1, 2, 3. This is 63 here. So 63 is located here on this line. So you can even put marks there if you get confused. You can put marks there. After plotting the point, you erase. Then now I locate where I have 186. This 184, 85, 86. So I have what? Yeah. So this is where they are intersecting. I plot. Now the next value I have is this thing, 100, and that's 78 against 278 and 207. 207 goes to 10 to the power y. 78 is located on the x. Remember. So I look at where I have 78. This is 76 here. So it means that beside it's 77, 78. So this line, you can make marks on it until you plot the point, and then later you erase. Follow that line and go up Now from there now, I'll plot 207 is located here. This 204, right? 205, 206, 207 is located here. This is the line where 207 is located. So from here, this if I extend this mark up here, I'll see that they intersect the here. Where they intersect, I place a dot there. That's where I plotted my point. From there now, I can remove these marks. I can remove that now. After plotting that point, the last value there is 94 against 227. This 96 is here. 94 will be here, right? Because this is 96, 97, 94. Then 95, then 94 should be here. I count that. That's 94. You can follow this line. It is located on these two lines after this. So I can follow it up. So it's located two lines after. So it's somewhere here. Then I locate now 227. That's 227. This 224, right? 225, 26, 25, 26, and 27 here. This is where they intersect. I plot. Now, that is how the graph has been plotted. From here now, I will link up these points with a straight line. Draw a line with a sharp pencil and you draw the line once. You draw the line once. Make sure the line connects the points as much as possible. So I'm drawing the line and it is drawn once. Make sure you have a sharp pencil once. So that is the graph I have. So I have this as my graph. That is how the graph looks like. Very neat and clean. Now the next thing is, like I told you, that you will not need these values here. You will not leave it here, right? They were just to help you to plot your points. Now the next thing I will do is this. I will now try to take 2 points on the line that I will use in calculating the slope of this graph. So I will take 2 points on that line. I will use, let me say I use this point here, right? So let me extend. After plotting, you draw a large triangle to show how you calculate your gradient. To show that you want to calculate the gradient from that triangle. So this is what I have. The next thing there is for me to know what is located here as my points. I'll just write with a pen so that you get it. From this point, if I follow this line, right, I want to know the whole number that is located here. From there, I'll be able to get the data point. The whole number is what? This is 36, right? 37, 38, 39 on the x. 39 on the x. So I go back to my values that I have here, right? Since the whole number part is equal to this, if I make the data point the subject, data point for x will be what? 0.32 times the whole number part for x divided by 5. I now come here to know the data point. Since my whole number part is what? 36, 37, 38, 39, right? That's 39. So I will take now 39 times this 0.32 times what? 39 divided by 5. And that illustrates to give me 0.32 times 39 divided by 5. It gives me 2.496. That's for the x. I do the same for y. This line here corresponds to what? The whole number I mixed here is 154. So I do the same thing for x, for y. The whole number part, data point for 10 to the power y, sorry. 10 to the power y. If you make 10 to the power y, the data point for 10 to the power y, you make z the subject here, you are going to have 0.29 on what? 5 times what? The whole number part, right? 10 to the power y. So for 10 to the power y, the whole number part here is what? 154. And now calculate that 0.29 into 154 divided by 5, right? So I divide by 5. So I'm going to have 0.29 times 154 divided by 5. I'm going to have 8.932. That is the point here. I do a similar calculation for the point here. I read off the data point for the whole number part on the x. This is what? 86. Observe this 86. So 86 represent what in data point? So I'll come here now and use the same formula. I'm going to take 0.32 times 86 divided by 5. I'm going to have 5.504. I do same for the y. If I project from here, this line, this one meets here, right? I read off this line, follow it. Okay, let's proceed. If I read off this point here, the corresponding whole number part I meet on this axis. Let me see. 1, 2, 3. Let me follow. 1, 2, 3. This is 214, 215, 216, and 217, right? So 217 is the value I have there. So I'll take, since I'm using this formula now to get the value on the vertical axis, so I'm going to take 0.29 times this 217 divided by 5. Still using this formula, that is for y. So it's giving me 12.586. Voila. Once I have plotted that, I can now remove these values. Make sure you answer all the questions relating to the graph before you remove that value. The second part of the question was asking us to get the value of y when x is 1.5, right? So when x is 1.5, what's the value of y? So I will just indicate on my graph so that I know exactly what I'm doing at the end. I will not regret. So I'll come and locate where I have x is 1.5. Since I don't know where 1.5 is located, I still use my whole numbers that I started with. So I know that the whole number part for x is what I have here. So my whole number part is 5 times data point over 0.2. So if this x is my data point, 1.5, so I'm going to take 5 times 1.5 divided by 0.32. I'm going to have to the nearest whole number is 23. I come and locate where 23 is located and read off the corresponding whole number part for y. And then from there I'll be able to know the value for x, for y. So this is 23. Where is 23 located? This is 24, right? So where is 23 located? This is 26 here. This is 16. 16 plus 5 is 21. 22, 23. So it's here. This is where 23 is located. You count 16, 17, 18, 19, 20, 21, 22, 23. 23 is located here. It meets at this point. I read off what I have here. Right? Since here is 134, means here will be what? 133. So I have 133 here. I can just demarcate that. So I can now erase all values on my graph except this one because it will help me to answer the other question. So that is what I have. Let me clean this off. Like I said, it's golf work, so it will not indicate on your answer sheet these marks that you made here. So I do the same thing here, but don't clean off this point that you will need here. So we clean it off so that our graph looks beautiful now. and it's advisable for you to use a soft eraser. Soft eraser. There are some that are very strong. When you use a soft eraser, the marks comes out easily. So you clean off all the marks. Make sure you clean it up until they are not showing. So I'm one step to answer my questions now. From what I've analyzed, the next question is asking us to get the values of using by drawing a linear graph. We have drawn a linear graph. This is what they call a linear graph, a straight line graph. Estimate the values of A and B. We said that A was what? The value A was what? For my analysis, A is the vertical intercept, right? The vertical intercept. And then my B is what? The gradient of my graph. So I'll first of all calculate the gradient of this graph. So I'll go now here. Gradient, also called a slope. Let me just denote it by S. The gradient of my graph, S, will be what? Change in Y. So change in Y, if this change in Y will be 12.586 minus 8.932. This is the values of Y divided by the change in X. So it's 5.504 minus 2.496. So that's what I have. You calculate that, I'm going to get let me see, here's my calculator. From there, let me calculate and see what I get. So I have 12.586 minus 8.932. So I'm going to have 3.854 divided by 5.504 minus 2.496, 3.008. So when you divide this, it's going to give me 3.654 divided by that. I'm going to have 1.21476. Then if I'm approximating to the nearest two decimal place, I have 1.21 as my value. So since A is the gradient of my graph, I mean B rather, so it means that B is what? 1.21. So that's the value of B obtained from the graph. Now the next is this other one. To get the value of A, we know that the graph, we cannot actually see where it cuts the vertical axis, right? But since we have contracted the two axes, we are not going to use a graph to calculate C, the value of A, that's the intercept. But from this equation, 10 to the power y equals bx plus c plus a rather. It means that my A will be equal to what? 10 to the power y minus bx. I'm going to use one of these points that I use in calculating my gradient, right? So I'll use one of those points to calculate my intercept A. So I'm going to take 10 to the power y. I'll use since these points lie on this line, means they satisfy this equation. This is the value for 10 to the power y. That's what we plotted on the vertical axis. So I have for 10 to the power y is what? Let me use this point. So it's 8.932 minus what is b? My value of b I just calculated is a gradient, which is 1.21 multiplied by what? The value of x. This is my x. 2.496. So let me evaluate that and see what I get. So at the end, I have 5.91. So 5.91 to the nearest 2 decimal place. So that's the value of A obtained from the graph. Now the next one, the Roman 2 of the equation says that we should find the value of y when x is 1.5. So I'll come now to my graph, right? Like, remember, I always have my rough sheet when doing this calculation. I come back to my graph. We said that 1.5 was represented by the line. 1.5 was represented by what? Let's calculate again. For the using this same approach, so it's 5 times 1.5 divided by what? 0.32. So that's 23, as we said. So this is where 23 is located. This is my 23 here. I read off what I have here. This is what? 134 for the whole number part, right? For the y. So I'm going to calculate 10 to the power y. 10 to the power y equals to what? This is my data point, right? My data point for 10 to the power y is equals to what? This formula, 0.29 times the whole number part divided by 5, according to this expression here. So I'm going to take 0.29 times whole number part, which we say is 132, right? So I have 132 divided by 5. That will give me what? 0.29 times what? 132 divided by 5. So I have what? 7.656. From here now, from this one, right? From this value, that is my 10 to the power y. So from the graph, I will just say from the graph, we know that 10 to the power y is equals to 7.656. It implies my y will be what? So I take ln on both sides, right? So if I simplify this using Napoleon logarithm, I'm going to have ln what? Or you take logs to the base 10 on both sides. You take logs on both sides to the base 10. You are going to simplify. But if you are using ln function, let me just illustrate that using the ln function divided by ln 10 when you make y the subject. Equally, you can have just log of that. So let's evaluate that. So I have ln 7.656 divided by ln 10. That will give me 0.88. So 0.88, that's the value I have for y. So that is exactly what we have. And now to even hence the relationship between the variables, we have y equals to what? Log to the base 10. You cannot, even if you write log without indicating the base, it shows that it's in base 10. So I can just have log of what? My a, which is 1.21, plus b, what's my b? Hey, a is 5.91 minus plus b. My b was 1.21 times x. So that's the relationship between the variable. To check that this data is very accurate, right? I go back to the original question and see. I go back to the original question and test. Look at it. This is the relationship, right? I see when x is 1, I come and replace 1 here. I'm going to have 5.91 plus, if you replace 1 here, you are just going to have 1.21. That gives me 7.112. If I take log of that answer, I'm going to have 0.8527. Look at on the table, we have 0.857. So the results, the answer, they are not very far from the truth. So this is the method I explored when I was in the secondary school. This is the method I use in plotting all my graphs. So this is how the works looks like. At the end of the day, once I've made my calculation, I can clean off this now. I clean off all the marks that I had. So this 16 here also goes. Remember, what you are cleaning off is just the one you use for the whole numbers. Your scale remains intact. That's why I wrote the whole numbers were inside, so that I will not get confused at the end. So look at how the graph looks. Is it not beautiful? Of course, it is very clean and neat. That is, it covers almost 100% of the graph paper, and that is how your examiner wants you to do during your examination. So make your graphs to be very large and neat. Follow what I have just done. Answer other questions, and please, if you are watching this video, make sure you watch alongside with a pen and a paper. Or if you didn't started watching with a pen and paper, restart the video, watch with a pen and paper. Why I am saying this, because if you are just looking at the paper like that, or just watching the video without doing the exercise, you'll not get acquainted to the method I've just shown you guys. So that is all I have for you guys for this presentation. If you are not subscribed to this channel, please subscribe. It's very important for me, so that will encourage me to create more content for you guys. Please share the video, comment, like, drop your comments in the comment section, because it will be very important for me to know what you guys really want to better serve you. Drop your comments, just drop your likes and dislike about this video, and I'll get back to you guys, maybe through replies. And on WhatsApp, you can get to me on the number 652186890. So you can get to me on WhatsApp using the number. This is +237. This is my country code, Cameroon, 652186890. That is my WhatsApp contact. This is on WhatsApp. Now you can email me on this Gmail. It's temgun48@gmail.com. So that is it. That is all I have for you guys. Like I said, if you are not subscribed, please, I am begging you, just press that red button written as sus. That button that you are seeing there, that's subscribe. Click on it. Make sure it is written in the form subscribe. Once it is written in this form, it shows that you have subscribed to my channel, and that will encourage me. And like my video with a thumbs up, right? Not a thumbs down, with a thumbs up. So once you have subscribed, share the video like I just said, and remember, I love you guys. Bye bye. See you guys in the next tutorial. I will teach you guys on how to plot graphs with negative quantities. Bye. So please subscribe, like I've just said, subscribe. If you don't subscribe, I'll come to your house. So this is my graph. Look at how neat it is. I'm just admiring the graph. So that's what I have for you guys.